Good morning, fancy meat computers. How are you today? I'm doing well, thank you. I'm doing okay. I have to drop by the hardware store and pick up a second garbage can because my first garbage can is not enough garbage can anymore because we now have two small entities in the house generating diaper trash. And it used to be like prior to the existence of the second child. We were like coming right up to our like the amount of garbage that one garbage bag can hold on a sort of a weekly basis, and now that we've just been pushed right over the top, so I'm gonna have to you know, it's kind of like it's either we're just gonna have to find a new way to deal with our trash. That's all. And find a way to store it so that rats don't eat the garbage bag, and then you just got a garbage everywhere. So, you know. So yeah, that's how my life is going. I'm thinking about getting extra trash bins. Also, I need to pick up a new three-way switch for the basement renovation because my wife's cousin, who's an electrician and got some various electrical supplies for the installation of the electrical down there. He got me some three-way switches, but I'm like 95% sure that one of them is faulty. I'm pretty sure it's not my wiring job. I'm pretty sure that the switch itself is faulty. So I'm gonna have to pick up one of those as well. Not to mention, I just need more 14 by 2 wire. Someone told me to check my email. I'll check my email this afternoon. I've got lots and lots of lecturing this morning. Sounds like quite the trip. Well, trip to the hardware store is always a bit of a trip. Yep. So it's like Richards is like broken image, copyright good, snake bad. Everybody who's saying snake is saying Python, I'm gathering. By the way, mine was like, while sleeping, spiders enter your mouth. That's what I was gonna say. Or Teams? You want me to check Teams? Is this some kind of prank? Am I being pranked? Oh. I think I missed a, yeah, I missed a meeting with you. Yeah, okay. I forgot about the meeting and you called me out during lecture. Congratulations. I'll reschedule you for some time today. We'll see how we go. We'll see how the day goes. Happy Remembrance Day. I think the correct terminology is have a solemn Remembrance Day. I'm not sure that happiness is the correct emotion. Yeah. Any updates on the TA strike? None that I've heard. The vice provost's office sent around a form letter for me to send to all of my staff, so that they can, manage my communication between, myself and the TAs. So, so lawyers continue to get involved, I suppose. Yeah. Solemn. Yeah, no trouble. So actually, since, a number of you are probably, you know, perhaps not of Canadian origin, or, perhaps you are from a part of the world that doesn't celebrate or recognize or observe Remembrance Day, I'd just like to take a minute or two to explain like what it is and what the significance is of the day. So Remembrance Day is the day that Canada and many other countries who basically won the First World War. It's the day that we take to honor our war dead. The First World War was terminated at the 11th hour on the 11th day of the 11th month. So at 11 a.m., there'll be, Remembrance Day services that you can tune into or take a look at and stuff like that. So, yeah, it's a very sort of, the idea behind Remembrance Day is that we should honor the sacrifice of those who died in order that we might have a world that's better to live in. And also to remind us that war is bad and that we should try not to engage in it whenever possible. We should, not allow the conditions that lead to it to arise again, or to try to avoid those. But yeah, my grandfather actually served in the First World War. He was a sergeant in charge of a military prison in Niagara Falls during the First World War, which is where they kept POWs that were sufficiently, sufficiently whatever to not want to keep them in Europe, but to ship them to Canada, or like domestic spies and that sort of thing. So yeah, if you have some time around 11 today, please take some time out of your day to remember the sacrifices of those who came before. But anyway, man, I should really be wearing a poppy on stream on Remembrance Day. Give me 2 seconds, guy. There. Maybe I'll just pin it a bit higher so that it can actually be seen on stream, eh? There. There we go. Good. So we go. Anyway, so with respect to announcements, I think we're all good. Let me just check to make sure. Ah, there's a good one. So we're going to be back to in-person next week. I know a number of you were wondering when we will be returning to in-person classes from our lecture streams that are currently ongoing. And that will be Monday. Wait, do we have class on Monday? Tuesday. I think it's Tuesday. Yes, Tuesday. Next week we'll be back in person. So this will be our last lecture online, assuming nothing else goes wrong. So, good. Right. So let's continue where we left off, eh? So we were talking about classes, and I said I remember my words finishing yesterday's class was, we don't have time to cover multiple inheritance in 2 minutes. So let's cover it now. So multiple inheritance, not a hugely difficult concept. Just sort of one more monkey wrench to throw into the gears. One more spanner in the works, as they say. So let's consider the manner in which we produced the colored point class from the point class, right? Essentially, we added some additional fields and some additional methods. Well, one additional field and one additional method, and overrode another method. All of this in the interest of adding this color behavior to our regular point class, right? Well, it turns out color is an attribute which could be used for many different things, right? It's a very general sort of a thing, right? Lots of things have color. So, if we embed all of this information, all of this calculation about how color works into the colored point class, if we wanted to do like a colored figure, or a colored volume, or a colored edge, or any other type of geometric figure which has a color attribute, we would need to, use our old friend copy pasta to, populate these fields and specify that behavior. A better approach would be to define a class for the color attribute itself, and then have the colored point class inherit from multiple base classes. So, class color, spelt with the King's English, define init self and color, and then self.color is equal to color. What is the difference between super and point.init and color.init? So the thing that was told to me last time when we were playing around with super is that super will sort of automatically look for the correct or a defined version of the method. I'm not sure how it picks the correct one if the method has been defined in multiple subclasses. So I'm going to just and besides, it's not covered in the slides, so I'm just going to just blow that out and replace it with a direct reference to the class itself. There we go. Point.eq, self and other. So, there we go. We can take this guy, put her in there just so, and we can define EQ, taking self and other, return self.color is equal to other.color. And there we go. So now we have a class for color. To change the colored point class so that it now inherits from both point and color, we simply include the second class in the parentheses with the first class. Now we're inheriting from two base classes. Ta-ra! Now we just need to modify this so that it is actually using that definition, right? So we can now say we initialize point and we initialize color, and we no longer need to define darken inside of colored point because it is now being provided by the class that we are inheriting from. And we can remove this explicit test and instead make reference to the equality method defined in the subclass. Init, what am I talking about? EQ, thank you very much. There we go. Boom. Nope. So you might ask, like, what's the point of this? Why go to such lengths? Well, any additions, subtractions, modifications, or bug fixes which occur inside of the color class will automatically be picked up by any class that's inheriting from that class, right? That's kind of like that's a lot of the point of inheritance, period. Like, for example, now that we have a colored point class, if, just for the sake of interest, we were to expand this definition to include a Z component, right? It's going to affect every place that point is used because we're modifying the interfaces to the methods. But you know, you can make these types of modifications as long as you're not, you know, if you make modifications to the ways in which methods are called, then that's going to have to be updated anywhere they're used. But you can definitely fix bugs and do other things that don't touch the interface inside of classes, and all of those good and wholesome changes will be picked up automatically by any classes inheriting, you know, with no muss, no fuss. And now the color class has been liberated so that we can use it now for other types of classes. For example, perhaps we wish to, you know, modify triangle to also, you know, have that attribute. In fact, I think that what we would be able to do is just one way you could do it is just directly inherit from color, you know, and then color dot init self, and then give it like white or something. And there you go. So question, then how can we change darken? Oh, it's simple. You just go into class color and modify it. So if you want to change it to, say, very dark yellow or whatever it is, or in this case, if we call darken on triangle with white as a default for the color, we would end up with very dark white, which is kind of funny. Slightly humorous. So there we go. So that's multiple inheritance. The color, it takes color and extracts it so that it can be useful to other classes. All right? Reusing code through inheritance contributed to the popularity of object-oriented languages. So it's because you can pull tricks like this that a good programmer can save themselves a lot of effort while sort of doing the day-to-day routine tasks. That makes programming in object-oriented languages more efficient at scale than programming in imperative languages like C. Not that C doesn't still have its place. If you're doing low-level operating systems like operations, C is still the language that you want because it's more efficient for, like, it's more efficient to write in. Like, programs are they just run faster if you write them in C. But at a certain point with programming, and you guys might already be at this point, who knows, efficiency becomes less of a concern, and the ability to produce the program becomes more of the concern. So you'll find that programmers are very often willing to spend some program efficiency in order to be able to develop more easily and quickly. Because any of you people who are sort of business savvy, what's the number one expense in any business? It's people. It's people. Nope. It's not. It's people's time. So, you can always buy more hardware for like a fraction of the amount of time or the fraction of the amount of money that it would take to employ one person for like a week. So, yeah. Yes, people's salaries. So, in this case, color only serves as a base class for inheritance. One would not create objects of that class as they are incomplete for practical purposes. Classes that only serve for inheritance but not for object creation are called abstract. Their purpose is code reuse. So, we would never imagine using the color class just on its own, right? If you think about what a color is, right? Like in terms of a physical phenomenon, a color is an attribute of a physically existing object. It is not an object itself, right? In the same way that sadness is not an object, but a modification on the mood of an animal. Color is an attribute of a physical object. So you would never, there's no such thing as a color in the absence of something which is colored, right? Exchanging efficiency for time is literally Electron's whole platform, right? It turns out that, making life more convenient for humans is big business. So, that being said, right, you do still require the ability to program at a low level to be able to produce highly efficient programs when that is necessary, right? Like a good programmer or a sufficiently experienced, well-developed a person with well-developed programming skills, shall we say. When they don't need efficiency, they'll use a less efficient language that's faster to program in. When they need the efficiency, they have the ability to pop down into a lower level language and, optimize at that level, right? Good. So, all right, let's do some examples, some additional examples. We're going to design, we have a couple of class programming examples, so these will be live coding problems, so please pull up your keyboard and get cozy. So, we're going to do birthday calendar. The task is to design a birthday calendar with the following operations. We want clear, add, contains, and birthdays. So, clear removes all names in the calendar. Add name date adds a name with a date to the calendar. Contains name checks to see if the name is in the calendar. And birthdays is the set of all names with birthdays on the specific date. This requires a data structure with entries for names and dates. The data structure is shared among the operations. A class allows us to encapsulate operations on shared data structures. Quick question. Would I consider it faster to code something in Python compared to something like C? Yes. Even though Python is a bad language, and like I've said this before, I kind of play up the Python is a terrible language thing to an extent. Like, if I had to do something that was reasonably heavily object-oriented in nature, Python would not be my choice. I would choose something better. Even Java would be a improvement. If I have a programming task that I have to do, like, formatting a CSV file for, grade transmission between Avenue and Mosaic or something like that, my go-to is to whip up a quick little Python script, right? Because, you can whip up that sort of thing in Python reasonably quickly. But generally speaking, like, I don't think I've ever, like, intentionally, I've never really, like, found a natural place for writing a Python program of more than, like, 20 or 30 lines, if that makes sense. Now, you can accomplish a lot in, like, 20 or 30 lines of Python because of all the libraries. But, yeah, something quick that I just need to get done and out, and it doesn't matter if it's, like, robust. I will just, throw I'll throw it into Python. Java is no improvement. The OOP there is just too hacky. Well, that's fair enough. Still, though, just from like a user interface perspective, it's still superior to Python because remember, in Python, for any variable that's bound to the class, you have to prepend with self dot, which is ridiculous. And, like, the way that it does public-private membership is just, like, blah. Like, Python falls flat on its face with the very basics of object-oriented programming, But, anyway. So, birthday calendar. So, class, B-Day, inherits from nothing. So, first class, while I'm typing, what kind of data structure do you want to use here? I have a suggestion of a dictionary. Okay, a dictionary from what to what? So we've got people suggesting we go from name to date. It turns out that you can do it basically, it doesn't really matter which way you do it. Going from names to dates makes one of these two methods easy and the other one a little bit harder. And going from dates to names makes the opposite one, the one that was hard easy and the one that was easy hard. So let's go with the suggestion given in the chat. Let's go from names to dates. Self dot, just call it lowercase d, is an empty dictionary. So clear or reset methods, like you would be tempted to just, copy this line and throw it in here, right? To do a clear or a reset. If you want to maximize code reuse, what you'd actually do is you'd go in here and re-invoke the initializer. That way, if you, add more fields to the dictionary or add more fields to the class at a later date, you don't have to remember to also modify the reset method that's already making reference to the initializer, right? Now, add should be fairly simple. Self dot d at name is equal to date. Bing, bang, boom. Contains checks if a name is in the calendar. This is fairly simple. Return name in self.d. Remember that the in operator searches the keys of a dictionary. Since the keys are the names, that's all that's required. Now for the tricky one. Set. The set of names with a birthday on a particular date. So, the easiest way to do this, I would say, is to just loop through all of the elements of the dictionary, examining as we go the dates, which are the values, and then collect up the corresponding keys. So I'll just make a local list in which to keep them for person, well, I can use name actually, for name in self.dictionary. If self.d at name is equal to date, then list append name. Good. And then, when all of that is finished, we return. It's asking for a set, so there we go. I just don't like working with sets for some reason. Well, we can do it as a set. Call it S. Is an empty set. S dot add, I think it is. Name. Return S. Let's see if that gets past the compiler. Ah. There we go. So that's correct Python at least. Whether it works or not is another thing. So calendar is B-day. Now we're going to actually add some stuff. So cal.add Nick 12th February 1988. Now you know how old I am. Add Felix is 1 for 2021 cal.add Cordelia. That would be 26th. I think it was the 26th. Forgive me for not having it. No, it was the 27th. Forgive me for not having it memorized yet. 10th month, 2022. Print cal.d. Print cal.contains alley. Print cal.birthdays. Let's see here. We'll whomever. There we go. So there we go. This is what the dictionary looks like. Alley is not contained in the dictionary. And the set of people with birthdays on that particular date is Cordelia and whomever. So there you go. Birthday calendar. So you can see that versus the slides, we have done pretty well. The only difference is they've included a method for the string conversion function, which wasn't actually asked for in the question. Incidentally, there is no requirement for you to add any methods to a class that are not asked for in the question. Normally in the question, we will even give you specifically like what's supposed to go in init in terms of variables you're supposed to be initializing. So don't worry about it. Okay, good. So, mean calculator. On to our next example. Class. Mean calc. Oh, unrelated, but I like using ISO dates in the format year, month, day since it's unambiguous. Using the format can mean month or day first, which can be confusing. Yeah, in general, I agree, Tony, except for one thing. Literally the only country in the world that uses month, day, year is the United States of America. So long as you're not an American, it's day month. It's day month year, small to big. So. So what is this thing supposed to do? We are intending to design a calculator to calculate the arithmetic mean of a series of numbers. This calculator has only two operations. We want to be able to add a number to the collection and return the mean of the collection. We're going to assume that they're integers in this case. Don't we have to capitalize the character of the class? Oh, yeah. Well, by convention, yes. There we go. They just have to do it, be different to do everything. Yeah, yeah. Don't even get me started on bloody Americans. So class names are not like syntactically required to be capitalized, but they are capitalized by convention. Def. Init. So while I fill in these constructors, or while I fill in the prototypes, how should we store this? What should be the underlying data structure here? Any ideas? A list. Yeah, not bad. Yeah, I think a list is fine. So, a set, a list. Well, see, the thing about a set is that a set can't contain repeated items, right? So because we might, like, it's valid to get, like, 4 3s and a 7 and want to calculate the mean of that, so we don't want a set in this case. But yes, lists, let's do it. So self dot L is equal to empty list. When we add something to the list, self dot L is concatenated with n, and in order to calculate the mean, yeah, you misread the slides as saying the opposite of what the slides said. That's fine. And then return the sum of self.l divided by the length of self.l. Sure, this should work. M is equal to mean calc m dot add 4, m dot add 7, m dot add 10, m dot add 2. Print m dot mean. The mean is this, but you could never have figured that one out because you're so stupid. There we go. The mean is 5.75, but you could never have figured that one out because you're so stupid. So we have a calculator that both calculates mean and is mean. Do we have to do try and accept? No, not in this case. What happens if we add a list? Oh, it wouldn't work. So m dot add 1, 2, 3, 4. Yeah. Basically, concatenation is an unsupported operation on this thing, right? It would be fairly easy if type n equals int, we do this, else, or elif type n equals list self.l equals or plus equals n without these braces which place it inside of a list. There you go. Does that make sense, what I just did? So, because of the particular way I'm like, this plus equals applied to a list is concatenation. if n is an integer, then it's just an integer. It's not inside of a list, which means that basically your situation would be, 1, 2, 3 plus 4. You don't do that, right? That's nonsense. Instead, you put it inside square braces. In this case, since it's already a list, you don't have to put the square braces around n because it's already a list, so concatenation works. Right? Make sense? There. So now we have a calculator which is even a bit more better than it was before. Good. So, there we go. You can see we're pretty much on point with the slides. So here's a question though, right? In this case, we're actually using a fair amount of pardon me. We're using a fair amount of memory here. More memory than we actually need to use. It turns out that you can calculate the same thing using running totals rather than list 1, 2, 3, 4 is the same as 10. Is the list treated as one argument? No, actually. So it doesn't like collapse 1, 2, 3, 4, right? It doesn't collapse those into one number because it has to add them to the list in order to have the correct length of that list in order to do the mean calculation. But anyway, we don't actually need to store things in a list. We can actually just have a running sum and a running count. So rather than adding it going like this, we would say self.sum plus equals n, self.count plus equals 1. And in the case of self.s, if it's a list, self.s plus equals the sum of n, and self.count plus equals the length of n. And then everything, and then to return the mean, rather than performing sum on the list, we just return self.sum divided by self.count. And then we can substitute. Let's call this something different. Mean calc 2. There we go. And you can see that nothing has changed, despite the fact that we are now using, instead of storing, n variables for calculating the mean of n numbers, we are now keeping 2 variables to calculate any number of numbers. Right? So, so that uses a lot less memory. This is now a situation where we would say we're using constant memory instead of linear memory. But what is the trade-off? Oh. The trade-off is that we lose flexibility. Certain other operations require access to the entire list. Imagine if you wanted to add, like, median or mode to this simple statistical package. You would definitely need to keep track of every single element in the dataset, right? Or if you wanted to do something even fancier like standard deviation, you would need that additional data, right? So you lose that flexibility, but what you gain is a far more efficient implementation that just does mean. And this is kind of, this is programming all over the place. It's like, lose generality, gain efficiency, right? But anyway, any questions? Okay. All right. See you next week, folks. Question is, can we see the cat? Let me just see if I can grab a cat. Sure. This is cat number 1. Actually, cat number 2, technically speaking. This is Marimba. She is a very fancy cat. At least she likes to think she's a fancy cat. Yeah. That's Marimba. And this is Martin. Yeah. He's a big boy. Yeah. He's half Maine Coon, half Bengal. There we go. All right. See you next week, folks.